The RMC project, co-led by the Lake and Butte County Offices of Education with partnerships to the Chico and North Coast Math projects, is one of 3 Learning Acceleration System Grant awardees in the state by the California Collaborative for Educational Excellence. Welcome to the Number Sense module. This module, based on guidance within the 2023 California Mathematics Framework, was created by the Rural Math Collaborative, a 5-year state-funded initiative to build and strengthen a system of support for robust math instruction amongst over 20 counties and dozens of LEAs in rural Northern California. Let's get started with Part 0 of the module, an overview of number sense from the 2023 California Math Framework. We encourage you to watch and interact with this module, including any of the grade-banded parts, with a colleague if possible. That said, we invite educators to watch on their own too, as the experience is powerful in that way as well. Greetings, this is Brian Lindeman. Throughout the various parts of this module, you will be hearing my voice and that of my 3 colleagues, Danielle Reynolds, Katie Early, and Michelle Sanchez. We are excited to share this part of the module with you and hope you find it beneficial to the students you serve. This is the full table of contents for the California Math Framework 2023, with the exception of Chapter 14, which is a glossary, and Appendix B, which is works cited. Chapters 1 and 2 set the stage for the vision of this framework to promote deeper understanding in why and how we can engage all students in meaningful math learning by connecting the beauty, relevance, and interrelatedness of mathematics to their lived experiences, past, present, and future. Chapters 3 through 5 describe progressions of learning that span all grades, TK to 12. Chapter 4 describes a progression of 3 standards for math practice, 3, 7, and 8. Chapters 3 and 5 describe progressions of learning in 2 key content areas, number sense and data science. Chapters 6 through 8 provide grade-banded guidance. Chapters 9 through 14 offer support and resources in applying the major focal points of Chapters 1 through 8 at a school and system level, in professional learning, by incorporating technology into math instruction, in assessment, and in the creation of new curricula, which are aligned with this framework. Various high school courses and pathways are described in both Chapter 8 and Appendix A. The classroom vignettes in Appendix C are referenced elsewhere in the framework and offer windows into the planning, implementation, and in-the-moment teacher decision-making for a variety of lessons and activities. Chapter 3, Number Sense, will be the primary focus of this module. These are the orienting principles of the 2023 California Math Framework. They are meant to help design instruction which enables students to experience math for a purpose, whether in a daily lesson, a longer unit, or even a short activity. The drivers of investigation encourage grounding instruction in approaches which open students up to wonder about something, such as making sense of the world, predicting what could happen, and impacting the future. The standards for mathematical practice, which are a critical part of the California Common Core state standards, describe 8 productive habits for students as they engage in their work as mathematicians. The content connections are 4 broad categories of content, each spanning TK to 12, into which all Common Core content standards and larger big ideas described in the grade-banded chapters 6 through 8 are situated. At any grade level, all students are reasoning with data, exploring changing quantities, taking wholes apart and putting parts together, or discovering shape and space. Taken together, these orienting principles can provide a coherent structure for lesson and task design in order to, driver of investigation, students will SMP while a CC. For example, in order to predict the 100th element of a pattern, students will reason abstractly and quantitatively while taking wholes apart and putting parts together. What is number sense? Take 1 minute to jot down 3 to 4 words or phrases that come to mind when you think of number sense. From Chapter 3, Number Sense. From the time a child can talk, and possibly even before, their relationship to the world is imbued by an understanding of numbers. Before any formal instruction begins, a child's understanding of numbers and the role that numbers play in life originates from a place of context. Given sufficient opportunity, young children naturally begin developing an understanding of numbers before they enter school. As they start to explore, children use numbers as a way to help describe what they see and to gauge their own place in the world. In the case of age, which is often one of the first uses of a number for a child, they see this number growing and changing as they do. When a child asks another child, "How many are you?" they are looking to utilize a numeric response to gain insight into others and to themselves, as they know that age indicates experience, growth, access to privileges, and so on. So what were some of the words or phrases that you associated with number sense? Possibly your list included things like basic number facts, or addition and subtraction. Similarly, your list might have included multiplication and division, or doing comparisons, such as big to small. Your list might have included the study of certain types of numbers, like fractions, or doing speedy calculations involving some of the operations above. Each of these is certainly an important part of what students come to understand as they work with numbers. The 2023 California Math Framework provides a great deal of helpful guidance to teachers, administrators, and parents on the topic of developing number sense. In Chapter 3, Number Sense, TK12. Chapter 3 is one of 3 learning progressions chapters in the new framework, designed to provide guidance around the teaching and learning of a particular theme along the learning continuum of grades TK to 12. The guidance for developing number sense incorporates 3 primary aspects, plus a 4th, more operating definition of what number sense is. The first aspect is fluency and flexibility. Second, number sense incorporates also efficiency and strategic reasoning. The third aspect of number sense is connecting algorithms to conceptual understanding. And lastly, the chapter provides an operating definition of number sense. We will go over each of these in more detail next. Let's first look at the fluency and flexibility aspects of number sense. Fluency means that students use strategies that are flexible, efficient, and accurate to solve problems in mathematics. Flexibility is thinking about numbers in a variety of ways, such as decomposing numbers and rearranging numbers to perform operations. For example, 17 plus 26 equals 10 plus 7 plus 20 plus 6, which equals 10 plus 20 plus 6 plus 7, which equals 30 plus 13, which is 43. In this manner, the 17 and the 26 were decomposed into smaller parts and then rearranged again. Another variation on this is 17 plus 26 can be thought of as 17 plus 3 plus 23, which equals 17 plus 3 plus 23, which equals 20 plus 23, and that is 43. In this manner, just the 26 was decomposed, and then some rearranging was done to perform the addition. Accuracy indicates the degree to which students' thinking can obtain valid results. Obtaining correct answers is, of course, desirable, but minor errors can give the appearance of invalid thinking when, in fact, the overall strategies were sound. Thus, as much as possible, assessment of learning should go beyond simple verification of correct answers. Let's look next at efficiency and strategic reasoning as another aspect of number sense. Efficiency refers to efficient use of prior knowledge. A great benefit of number sense is that students do not need to memorize seemingly endless sets of facts. By using known facts to determine unknown facts, they are developing greater number sense and reinforcing facts that they already know. They understand, for example, that the product of 4 times 6 will be twice the product of 2 times 6. If they know 2 times 6 equals 12, then 4 times 6 equals 2 times 12, or 24. Efficiency, or fluency, should not be equated with speed. Research has found that, quote, time tests offer little insight about how flexible students are in their use of strategies, or even which strategies a student selects. And evidence suggests that efficiency and accuracy may actually be negatively influenced by time testing. That's from Kling and Bay-Williams, 2014, page 489. By de-emphasizing time tests and emphasizing instead the use of prior knowledge, which needs time, children are better able to build upon what they know, thus achieving greater retention. Number sense also is about connecting algorithms and facts to conceptual understanding. Fluency is more than the memorization of facts, procedures, or having the ability to use one procedure for a given situation. Fluency builds on a foundation of conceptual understanding, strategic reasoning, and problem solving. To develop fluency, students need to connect their conceptual understanding with strategies, including standard algorithms, and prior facts, in ways that make sense to them. Let's look at 4 times 3. Pause for a moment and consider, what are the visualizations that come to mind for you as you think of 4 times 3? There are many. For example, students could visualize or draw this as jumps on a number line, or as 4 groupings of 3 objects, or a 4 by 3 array, or as the area of a 4 by 3 rectangle. Each approach offers students another way to connect their knowledge of facts and algorithms to other areas of mathematics, such as geometry, measurement, and the number systems, thus setting the stage for more powerful learning to follow. Let's next provide an operating definition for number sense. The operating definition of number sense for Chapter 3 in the framework is a form of intuition that students develop about number or quantity. As students increase their number sense, they can see relationships between numbers readily, think flexibly about numbers, and notice patterns that emerge as one works with numbers. While students enter school possessing varying levels of number sense, research shows that this knowledge is not an inherited capacity. Instead, number sense is something that can be improved, although not necessarily by direct teaching. Moving between representations and playing games can help children's number sense development. The acquisition of a rich, comfortable sense of number is incremental and is enriched by play, both inside and outside the classroom, when educators encourage, recognize, and value students' emerging sense of number. It supports their growth as mathematically capable, independent problem solvers. Okay, let's pause for a moment and jot down a few ways that you think numbers are used by the following age groups: 5-year-olds, 8-year-olds, 13-year-olds, 17-year-olds, and 34-year-olds. How do children in TK use numbers? In transitional kindergarten, TK, students count as they play games, sing, or count their age. How do children in grades K through 5 use numbers? Elementary age children make comparisons. Who has more? Keep score. And tell and track time. How do children in grades 6 through 8 use numbers? As preteens, they pursue more personal and social interests, and numbers play a role in helping them make decisions about saving and spending money, scheduling time with friends, and managing free time. Extracurricular activities such as music, athletics, video games, and other entertainments present situations that also call for numerical thinking. How do children in grades 9 to 12 use numbers? As adolescents start to gain a measure of independence, they rely on numbers that inform their decisions about budgeting, working, and saving for future endeavors. How do adults use numbers? Adults use numbers on a day-to-day basis in their jobs and in activities such as cooking, shopping, balancing household finances, and other activities in their communities such as fundraising. In short, a strong foundation in the use and understanding of numbers developed throughout the school years is critical in preparing young community members to continue to make sense of the world and to make wise decisions as adults. Let's now look at how the major focus areas for number sense at each grade level progress in the continuum from TK through 12th grade. Students in grades TK through 2 organize and count with numbers, which gives them more power to numerically describe their world, a great power indeed. They also compare and order numbers on a line in these grades for the first time. Lastly, they operate with numbers flexibly, exploring addition and subtraction, and often shifting between visual, numerical, and physical models. In grades 3 through 5, they extend this flexibility with number as they understand the more advanced operations of multiplication and division. They use number lines as tools to carry out these newfound operations, and as tools to work with larger and smaller numbers, such as making sense of operations with fractions and decimals. In grades 6 through 8, the number line model continues in importance as they study proportions, ratios, percents, and relationships among these. They also begin to see numbers in more general ways, and how letters can stand in for numbers in expressions, which sets the stage for algebra. In grades 9 through 12, they see intrinsic parallels between numbers and functions, such as linear and quadratic, including how operations such as addition and multiplication have predictable effects on the graphs of functions. They also develop an understanding of real and complex number systems, how these systems arise, and how they relate to previously studied number systems such as the integers. On a practical level, their number sense is further developed into financial literacy, which helps develop sound judgment in weighing financial decisions. Many examples and short snapshots of how these are developed in classrooms are provided throughout Chapter 3 of the framework. See the whole chapter at this link. We hope you have found Part 0 to be informative. The remaining 4 parts of this module will explore each of these grade bands in more detail, starting with Part 1, Counting and Cardinality in grades TK through 2. Thank you, and see you in the next part.
So we've just spent some time thinking about the mathematics in the framework, particularly the number sense chapter. In addition to mathematics, we also want to consider how we are integrating social emotional learning principles into our mathematics instruction. Consider the question above and jot down a few of your thoughts. Self-awareness, social awareness, and relationship skills are some of the areas that can be developed in students as they engage in mathematics. Some students may need more support and encouragement to discuss their thinking publicly. However, with continued intentional experiences integrated into our learning environments, students will continue to increase their social emotional competencies and therefore increase their sense of agency. Let's dig a little deeper into the big ideas of social emotional learning and some specific connections to number sense. The Collaborative for Academic and Social Emotional Learning, or CASEL, has defined 5 core competencies of social emotional learning, SEL. Those competencies include self-awareness, or the ability to accurately recognize one's emotions and thoughts and their influence on behavior. This includes accurately assessing one's strengths and limitations, as well as possessing a well-grounded sense of confidence and optimism. The second is self-management. This is the ability to regulate one's emotions, thoughts, and behaviors effectively in different situations. This includes managing stress, controlling impulses, motivating oneself, and setting and working toward achieving personal and academic goals. Next is social awareness. This is the ability to take the perspective of and empathize with others from diverse backgrounds and cultures, to understand social and ethical norms for behavior, and to recognize family, school, and community resources and supports. Our fourth competency are relationship skills. These are the ability to establish and maintain healthy and rewarding relationships with diverse individuals and groups. This includes communicating clearly, listening actively, cooperating, resisting inappropriate social pressure, negotiating conflict constructively, and seeking and offering help when needed. And finally, we have responsible decision-making. This is the ability to make constructive and respectful choices about personal behavior and social interactions based on consideration of ethical standards, safety concerns, social norms, the realistic evaluation of consequences of various actions, and the well-being of self and others. In addition, Castle has identified 4 general approaches to SEL instruction in the classroom. The first are freestanding lessons that provide explicit step-by-step instruction to teach students the 5 core social and emotional competencies. Second are general teaching practices that create classroom and school-wide conditions that facilitate and support social and emotional development in students. Third is the integration of SEL skill instruction and practices that support SEL development within the context of an academic curriculum. And finally is guidance to administrators and school leaders on how to facilitate SEL as a school-wide initiative. Throughout these modules, we will focus on how to integrate SEL skill instruction and practices within the context of our mathematics instruction.